So here we have an example of a piecewise function, and we're going to graph this piecewise function. So we're going to do it in two parts here. We're going to look at the top part, which is for x values, inputs, that are less than 2. So I'll make a little table of values here. Let's see. So yeah, x has to be less than 2. And then when we do that, we're going to use the negative x squared, or the opposite, I should say, of x squared. So think of numbers less than 2. Let's see. We'll put in -2, and -1, and 0, and 1. And we have to put in 2. We have to do that because that's the stopping point. We can't put in, like, well, we could put in like 1.999, but it's going to be really hard to graph it. And there's another number that's closer to 2 than 1.999. You know, you can put another 9 on there. Okay, so we have to use that 2 as the stopping place. Okay, when you plug in -2, you should get an output of -4. Plug in -1, you should get an output of -1. Now, if you have trouble doing that, go back and practice, but you're doing the opposite of -1 squared. You got to square the -1, then do the opposite of that. Okay, putting in 0, we're going to get 0. Putting in 1, we're going to get the opposite of 1, -1, and we're going to get -4 here at the end. Now, because it doesn't equal 2, we have to have this be an open dot. Okay, so I always like to write that down because I'm afraid I'll forget otherwise. But when I go to graph those points, then I have -2, -4, -1, -1, 0, 0, 1, -1, and then this open dot there at 2, -4. Now, it should look like a parabola. We should be thinking parabola. In fact, we should be thinking upside down parabola, okay? So it's helpful when you look at these functions and the pieces, when you see that x squared, you go, oh, that graph is going to be parabolic. All right, so we're going to draw this, try to draw it like a parabola. And I have to stop at that open dot. However, this other part continues. The graph just shifted, which I did it with this so that that wouldn't happen, you know. Wouldn't happen anyway. And now I can't get it lined up. Okay. Let's, I don't know if it's lined up or not, but you get the point. Okay, so that's how that piece looks. Now we're going to do another table of values for the bottom part, I guess, when x is greater than or equal to 2. And then we're going to use 3x. Now, when you see 3x, what shape are you thinking that is? Hopefully you're thinking it's linear because of this, and that it has a slope of 3 if you want to think of it that way, and you know, you can think more, but we won't. So we need x values greater than or equal to 2. We'll have to use the 2, and then 3, and I'm just going to do 2 points. It's just going to be a line. Okay, you could do 4, but my graph paper's not quite that big. All right, when you plug in your value then of 2, you're going to get 6. Plug in 3, you're going to get 9. Because we're using that 3x, right? So 2 times 3, and then 3 times 3. Okay, when we graph these, oh, by the way, that 2, 6, that ordered pair, that's going to be a closed dot, right? Because it's equal to, x can actually equal to in this case. All right, so let's go to 2, 6. 1, 2, 3, 4, 5, 6. Right there. And then 3, 9 is going to be right here. Be careful when you draw this. I see students make mistakes on this sometimes, but we're graphing from here on. Don't make it go in both directions because then it wouldn't be a function, right? You'd be, it wouldn't pass the vertical line test. So you've got to stop there. This does pass the vertical line test. It's a beautiful graph of a piecewise function. So there you go.